Like.
No.
What?
Awful. Awful.
I want to see that.
No.
He's like, full
Like,
smoke, and then
going to
it's
have to
like,
call
goes
an
like that, and he,
ambulance.
like, pops, like,
It's
six.
gonna be
It's gonna be like a chiropractor.
Ugh.
He wanted to.
Okay, let's look at this. So, for this graph, I want to put the following in increasing order. So, small to large. So, 0 is kind of an easy one. We know what 0 is. The rest of these are prime. So, that means the derivative. So, when I'm finding the derivative at -2, what does derivative mean? It's instantaneous velocity. It's also a rate of change. It's flipped to the very first in our notes
With
packet.
respect of x when x equals a instantaneous rate of change.
So if you look at the very beginning, the first thing we talked about was, I think it was the first, tangents. It's the slope of a tangent line. So a derivative has a lot of different meanings, a lot of different applications, but in terms of graph, it's the slope of a tangent line. Now we know a tangent line is a line that kind of hits our graph and bounces off. Okay. Now obviously we are kind of eyeballing this, so our lines are not perfect, but it's the slope of this line. So at the very least, I know this is a positive slope, right? G prime of 0, what kind of slope would that one be? Well, if I'm doing a tangent line there, that line would be decreasing. So this one would be negative. So it would have to be before my 0. So I know G prime of 0 is negative. I know 0 is or 0's next, and then this was a positive. G prime of 2, is that one a positive or a negative? Positive. Okay, and I have to somehow, now obviously this is not perfect, so these two are pretty close. G prime of 4, is that positive or negative? Also positive. So I know G prime 0 is my only negative, and 0 will come after that. These three are all positives. So which one would be the smallest? So basically the least steep of those three lines. G prime of 4. I think we could agree with that. These two, it's a little harder to tell, so let's give it our best shot. Which of those looks steeper? -2 looks a little bit steeper. If I put this exact question on a test or quiz, I would probably allow you to put the G prime of 2 and -2. If you flip those, that would probably be okay, because it's really hard to tell there. But the other three were pretty cut and dry. I knew the G prime of 0 was negative. I know G prime of 4, while it's a positive, it was not a very steep line, and those would come after. All right, any questions on that one? So then we did example 7 and 8A yesterday. Let's look at 8B. Alright, so I am asking on these, we are supposed to find f prime of A. So remember, f prime of A is the derivative. So it's the limit as h approaches 0, f of a plus h minus f of a all over h, which is what the majority of your homework is having you do. Sometimes I might give you a number to plug in for a, but I did not on this one. So if I work through this, we have the limit h approaches 0. F of a plus h means I plug an a plus h in for my x. Can I write that as 1 over x squared? Would that be okay? Negative exponent moves it to the bottom. So it'd be 1 over a plus h squared minus f of a would be 1 over a squared all over h. All right. Let's go ahead and multiply out to a plus h squared. Can I plug in my h right now, my 0? No, because we're getting 0 on the bottom of the fraction. Okay, if you want to add or subtract fractions, what do you have to have? Common denominator. So what I need to do is get a common denominator on the top. So to do that, I'm going to have to take this first fraction times a squared on top and bottom. And this one we get a squared plus 2ah plus h squared on top and bottom. Can I go ahead and write those as one fraction, since I know the denominator will match? So it'll be a squared times a squared plus 2ah plus h squared. And on the top I would have a squared minus have I lost? We are really close now. What would I need to do with this negative? So these drop. We have negative 2ah minus h squared over this denominator. This h on the bottom, I could treat that as an h over 1. And how do you divide fractions? So I would be multiplying by 1 over h. What would happen now? Yeah. If you don't see it on the top, we have a greatest common factor of h. So if you took out an h, now I can cancel one of those h's from each of them. So I took out the greatest common factor on the top, which was an h. And we can take an h out both top and bottom. At this point, we are no longer getting 0 on the bottom. So if we plug in 0 for all of our h's, we have negative 2a over a squared times a squared, and the rest of those terms would be 0. So if we reduce, we get negative 2 over a to the third.
So what's A? It's just like
A is basically representing any x value. So we could just keep it as x's, but your book teaches it as a at the beginning, so it's not confusing that the original function had x, so you can see you're actually plugging something in. But a just represents an x value. So basically now, for any x you might give me, we could plug it in and we have a formula for how we would find the slope of the tangent line at that particular point. So if my x were 1, the slope would be negative 2. If my x were 2, slope would be negative 1/4. We could do it quickly instead of working it out over and over and over again. All right, questions there? Definitely want to do the next one. I have to look at one with a radical. want the derivative. So the limit as h approaches 0. F of a plus h. 4 over square root of 1 minus a plus h minus f of a all over h. Okay, with me there? Would it be okay if right here, instead of writing 1 minus the parenthesis a plus h, can I go ahead and distribute the negative and write it as 1 minus a minus h? Alright, can I plug in yet? No. Okay, so if I can't plug in my h, what can I do? What am I going to have to do with these radicals? Yeah, this one's going to be kind of ugly. I promise the examples I'm doing are uglier than your homework ones. Does that make you feel better? So, to get my common denominator, we are basically going to multiply this one by radical 1 minus a on top and bottom. This one, we get the radical 1 minus a minus h. And my denominator would now have both of those. All right. Not pretty at all. Have I lost anybody? This is like an h over 1, right? Would it be okay if I went ahead and wrote this times 1 over h, multiplying by the reciprocal? So, we really just have one big fraction. I'm going to pull out this 4. You don't have to, but just want to make it just a touch easier. I still can't plug in. But what could I do to get the radical? I need to get these out of my radicals so something would cancel. What could we do? That's what I'm doing when it's adjacent. What's our strategy with radicals usually? Conjugate.
This is not pretty.
I know, but I'm doing it with you. Okay. I promise we are close. So we have the 4. Alright, when I multiply these out, the 1 minus a, so I multiply those, the square root cancels. When I multiply those, the square root cancels. On the bottom, I'm not going to multiply out any of it. I just want to leave it all. But now what happens on the top? If if I distribute that negative, positive 1 and negative 1 cancel. Negative A and positive A cancel. So we have 4h over this big nasty denominator. And now, what can we do? And then you can plug in. So if I make all my h's 0, we have a 4 on top. This would be a radical 1 minus a times a radical 1 minus a. And if you multiply those, what happens to the radical? Okay, times, this would be a radical 1 minus a plus a radical 1 minus a. That would be 2 radical 1 minus a. You can do things to simplify this. I'm not really going to require much. So all of our rules that you can't leave a radical on the denominator and that kind of thing, I am not going to make you do all of that here because obviously we've done a lot of nasty algebra to this point. The only thing that I would ask that you do on this one is reduce the 4 and the 2. So we have 2 over 1 minus a. And the square root of 1 minus a. And like I said, we certainly could simplify that some more, but I am not going to ask you to. Alright, so that was definitely uglier than the one I gave you on homework. I gave you one with a radical, but mine had a radical and a fraction, which is what made it so nasty. But basically with that radical, your strategy, you're going to have to remember multiplying by the conjugate. It doesn't go away. So I'm actually going to stop here. I know there's a couple examples left, and we're just not going to worry about those right now. I am also going to remove problem 39 from your homework. That's like one of the examples that I haven't done yet, and we'll just hit that later on.